5, using household measures in pharmacy calculations. That's page 133 on your textbook. So, when you look at the word household measures, think about the things that are in your house that you use. And if you look at table 5.1, which is on the first page of the chapter, these are things that you pretty much see in your house. Tablespoons, teaspoons. When you look on a carton of milk, you'll see fluid ounces. When you're making a cake, you have cups. Again, milk in pints and quarts. And the weight, and remember, volume is how much fluid is in a certain amount of space. And weight is how heavy something is. So, pounds. Another type of household measure that they also call it standard. Because it's the American standard. Because Americans use cups, pints, quarts, ounces, while the rest of the universe is chapter 3 and 4. The rest of the world used chapter 3 and 4. Now you may ask, why are we learning multiple systems? You learn multiple systems because many of the drugs that we import into this country are, because of the rest of the world, are in the metric system. And a lot of the things that we do in the office are in the standard system or household measure system. Another system that's similar to this is also called the apothecary system. Apothecary is the old-timey version of what the pharmacy used to be. So these are some household measures. Now, not really going to have to memorize this. It will be within the problem set. But the one thing you definitely have to memorize from chapter 3 and 4 is 1 pound equals 2.2 pounds equals 1 kilogram. That's the one thing. But most of the other conversions, it'll be usually within the problem itself. And remember, for the final examination, you'll have two kinds of questions. You will have multiple choice, and it'll be multiple choice math questions where you'll have multiple choices between the answer and fill-ins. Now the fill-ins are pure, it's all you. Whatever method you want to put in to get the answer, that's it. I advise to show all work because even if your answer is mathematically wrong, I will give you some credit if it follows a train of logic.
So 1 teaspoon is
1 teaspoon,
5 ml.
Like 1 whole tablespoon. And this, the other conversion is that we're going to be going on later in this chapter is the conversions from household to metric. That's more important than these conversions right here. But just right now, these are just some examples of what is a household measure. Because what question could it be? I could have a question is a teaspoon, tablespoon, and an ounce. Is that metric or is that household or standard? It's standard. Because remember, the rest of the world runs through metric. So these are the household or the standard system is things that you most likely will see in your kitchen.
So you said a gallon of milk is 4 quarts.
Mm-hmm. So a gallon of milk, 4 quarts, and that is household measure or standard. So let's say, for example, I have 2 gallons. How many quarts will I have? 8 quarts, and so on and so forth. This conversion is nice, but there's a better conversion that you need to know later on in this chapter. So here's some more conversions. Teaspoon is very different from a tablespoon. A teaspoon, which is usually 5 cc's or 5 ml, 3 of them equal 1 tablespoon. And 2 tablespoons equals 1 ounce. 8 fluid ounces equal 1 cup. 2 cups equals a pint. 2 pints equals a quart. 4 quarts equal a gallon. So if you can get this page down, and I like this page better than the previous page because it's visual. Mm-hmm. I can see it. Like, oh, 3 of those little spoons equal, 1 big tablespoon. 2 of those tablespoons equals 1 cup. 8 fluid ounces equal a cup. 2 cups equal a pint. So let's say, for example, you're mixing something that requires 4 fluid ounces. I don't have an ounce cups available. I can take what? A cup, and you know it has gradations on it. I can do what? Half a cup, and that's 4 fluid ounces. Many times you could also see the little cups that come with a lot of the pediatric meds. They have multiple lines on what's a cup, what's an ounce, what's a teaspoon.
One?
Yeah, the small little one. Okay. You'll see they have little gradations. In MED not MED 140, in your pharmacology class, they should be showing you like how to properly inform your patient on how to read that. Because remember the meniscus, remember that little bubble that forms usually on all liquids, right? You should be reading it where? At the bottom of that bubble, not the top. You could be missing out on meds. And also what I also like to do, especially regarding syrups and whatnot, I flush out the little caps and the little cups with water and have the patient drink the water that I flushed it out with, so that they can get the full amount of the medication. Okay, so that's a better picture than.
Yeah, that was my question about a gallon.
Yeah, so it's easier.
I like the picture better.
Yeah, the picture is much easier to figure it out. Okay, so you could be asked, and we'll go over some examples on conversion questions. Now, this is the thing, these dosing spoons. These are the things that these little droppers and these little spoons, you should be able to inform mommy. Even because most parents will do what? They'll just read the side of the label. Okay. Sometimes that's ill-efficient. So make sure that when you're dispensing, that they understand how to use this. I've had patients crush pills and then mix it with water and then do all sorts of crazy things with these spoons and these little droppers and the little cups. And there's much room for error. There's much room for over and underdosing. Because remember, underdosing is just as bad as overdosing. Underdosing, then my patient isn't getting what they need. Overdosing, my patient is getting more than what they need, and there's a potential for adverse side effects, or increased adverse side effects. So, let's look at a typical problem. How many teaspoons are in 2 tablespoons? First of all, you have to know the equation. So let's go on the board. And that's one. And the equivalency method or the ratio proportion method that they use in the textbook is viable. You could take one conversion, which is 3 teaspoons to 1 tablespoon, which is this, right here. That's where they got this conversion. And then what are they asking? You're asking for how many are 2 tablespoons. So 2 tablespoons, and then you could do inequality. You solve for x, right? Cross multiply. So 1x, 2 times 3 is 6. So x equals what? 6 teaspoons. And remember, teaspoons, in real life, it's better to write them all out, because can you see how close these two look? TSP and TBSP. Remember, you really need to know both, because a lot of old school pharmacists still use these things, but just pay close attention.
So how did you get the 2? If the problem was 3 tablespoons,
yeah,
equals 1 tablespoon, how do you wind up with 2?
Right, because that's what they're asking.
Okay.
Right? Let's look at it another way. Okay? That in your textbook is one way to do it. You could set up a ratio and make them equal to each other. Here's another way, and you know I always give you alternative methods. So let's write everything out that they want. How many teaspoons, right? And I'm going to write down the whole word. So they want to know how many teaspoons are in 2 tablespoons. Okay? You already know the conversion of those 3 little spoons. Right? 3 teaspoons equals 1. You already know that conversion. Right? Now, My method, which is just as viable as that one, right? I always start with what I know. Because I have 2 tablespoons times blank, and what do I want? Teaspoons. Okay? I just set that up, no brainer. I'm not thinking anything right now. See if I'm capturing my whole box. There you go. I'm not thinking, I'm just setting it up. What I start with, what I don't know. Now what I don't know is the conversion. How can I do the conversion? Well, what I want is teaspoons. So teaspoons will always go on top. And I know the other part of it is what? The tablespoons. And what do I know? 1 tablespoon is to 3 teaspoons. I just put them in the right places. And then just do the math. The tablespoons should cancel out. 2 times 3, 6. This is another way to look at it. I like this. I like my method better because the equality method, the other method that's on page 135, sample 5.1.1, you start doing algebra. And I don't like algebra.
Yeah.
I like simple. Right? But either way, you do either way, it'll get you the answer.
Okay, so.
Which, by the way, the solution option number 2 on page 135 is my version. But this is how I've been doing it since the beginning of this particular class.
So
I've been
you
doing
matched them
what I
up.
know, right? I put in what I know is what I know, right? Times some conversion, and I put it in blank, and then what I want. And did you see I purposely put what I want on the top, so that it reminds me that on my conversion, the thing that I want has to be on the top, because the other thing should what? Cancel. Okay?
So you match the tablespoons up with the tablespoons, but on the paper it says X teaspoons equals teaspoons, and tablespoons are at the bottom.
Yeah. If you look at solution number 2, it's exactly like mine. But solution number 1 is the equality ratio proportion method. The ratio proportion method, I find, most people find that more confusing. I find this method faster and easier. Because if you look at the ratio proportion method, there's 3 steps to it. On mine, there's only 1.
So X basically is 2. You know, because they're looking for what 2 is.
X is whatever's missing. This box is X.
So if X is 6, then Y is 2. 2 times 3 is 6. So I'm thinking that 6 is going to be 6.
What do you mean is X is 2? This
Right
is not
here.
X, this is multiply.
Now on the board, it's confusing to me.
Okay, which part?
because Here is 2,
Yeah.
and then 2, 2. You saying that the answer is 6. So if you said X is 6, 6 times 3 is 18.
If you look at this. This is equality, right? In order to get rid of this and this, let me draw item number 1, and you'll see.
You see what I'm saying?
Yeah, I see what you're saying. They're not showing all the steps. Let me draw, and this is from page 135. The thing that I'm going on the board. This is the same question, but it is the ratio proportion method. And we got to get this thing down because about a third of your problems are this thing. So this is what we know, right? We still have the same thing. How many teaspoons are 2 tablespoons? Okay, it's the same thing. And then you also have to know the conversion. Now I'm doing it. We always know that 3 teaspoons equals 1 tablespoon. It's the same thing. Now, the ratio proportion method does this. How many teaspoons, right, are in 2 tablespoons? And then you match it up to this equality. Right? So that's what, 1 tablespoon? 3 teaspoons. Because you see the t's have to be equal, and the tables have to be equal. Now, if you remember your Math 110, what can you do on an equality? You cross multiply. So it'll be x t's multiplied by 1 tablespoon equals 3 t's multiplied by 2 tablespoons. Right? We know how to do that. Okay? Because remember the property of an equality? You can cross multiply. So if I do that, right, I have to get x teaspoons, because that's what I want. X is always what I want. In order to do that, what must I do? Because I must divide, I've got to get it alone, so what must I do? I must divide both sides by this 1 tablespoon. And then, what do? These two will cancel out. 2 over 1, these two cancel out. Right? Oops, oops.
Yeah, it's just like...
My bad. I wrote it wrong. Oh no, it won't cancel out. Table, I'm right. Right the first time. Right? So, if these all cancel out, so this, they're gone.
So what leaves you with the x teaspoon times...
So those all disappear. X teaspoons equals 3 times what? 2. And what's the answer? Just like before, x equals 6 teaspoons. So you can see how many more steps. That's why I don't like the ratio proportion. There's too many steps. But you could see how that the one part that they don't show in the book, like how they figured out how they do all this mathematics in between. They just assume, because can't write every single step in the book. But so once everything starts canceling out,
the ratio and proportion. Right?
Yeah, this is ratio and proportion version. And once you get this algebra part down here, a whole bunch of things starts canceling out. And when they cancel out, what are you left with? X teaspoons equals 3 teaspoons times 2. And x equals then what? 6. Then you can ask yourself, does it make any sense? If 1 tablespoon equals 3 teaspoons, if I have 2 tablespoons, then it's got to be what? It's got to be twice as much. So, 6 teaspoons. You could use common sense to try to solve the problems, but try to do it mathematically, because in real life it won't be that clear. In real life it'll be like some bizarre thing, like 1.5 tablespoons divided by like 15 different tablespoons. It'll be just some weird thing, because patients and doctors do weird things, and they should prescribe weird things. Because remember chapter 3, not even chapter 3, chapter 4, even chapter 2, we talked about customizable medications. Many medications are based on the patient's age, weight, and height. So once you start putting those numbers in, it gets really complicated. But for this particular class, we're not going to do any complex math. We're just going to go through the process, so that when it's your time to start doing the complicated math, you at least know the logic behind it.
Question, but are we going to, on the midterm or quiz, will there be anything where we're looking for tablespoons and teaspoons at the same time?
No, we'll only be looking for one thing at a time.
Okay.
Nothing in this textbook would be, even if you look ahead, if you look at all the math that are in the textbook, they purposely picked numbers that were even. Okay? So if you're looking, especially in the multiple choice section of my midterm, if you see a number that's like ridiculous, like 24.25 pills, don't pick that one, because that's weird. It doesn't make any sense. Or if you're this thing is like divisible by 3, right? Let's say you were given choices like 52, 1, and 3, and 6. The only 2 choices that you most probably have is what? 3 and 6, because they're divisible by 3. you could use it that you could use that kind of logic on the midterm to eliminate answers for your multiple choice problems. But this is pretty much the bread and butter of your about a third of your fill-in parts. Now the exam anywhere from 40 to 50 items. Maybe I haven't written it up yet, but I usually put around about half fill-ins. So the exam will go. You'll have an hour for the exam, but it'll go by pretty fast. And especially if you get the dimensional analysis method or my method. I call it the no-brainer method because I don't have to do any real algebra. If you saw my method, I'm not using any algebra. I'm just setting it up and then doing what? Let the math take its course. This, you have to set it up, you have to understand what's going on, and then you have to make sure your algebra is okay, and then you can answer it. But you could see how easily you could lose track of it.
Can I say that whatever the denominator is, can I put it for the numerator when it comes to teaspoon and tablespoon?
Yeah, like let's say for example, you want to do it the other way. Like you want to switch this and switch that. Yeah.
No, that's not what I'm saying. So since 2 was on top, times the 3 equals 6, can I say, because 2 is the tablespoon, can I say 2 for the teaspoon? So in a case where it say 6 is the tablespoon, can I put that 6 in the numerator spot?
Yeah.
And that right there will give me whatever it's asking for teaspoons or
Yeah.
tablespoons?
So let's say for example, because this, let's erase all this.
You understand what I'm saying?
Yeah. You want to know where to plug it in.
Right.
Let's say for example, let's change the problem, and you want 6 tablespoons. You want to know 6 tablespoons. Then what will change? This.
So we're going to put 6 on top. 6 times 3 is 18. That's the answer. Or
Yeah.
that's not the answer.
Yeah, it is. You're right. Because I have 6 tablespoons, and I have 3 teaspoons per tablespoon. It's 6 times 3. Remember? X.
No.
6 times 3.
You're
18.
It's not 18.
Yeah. It's 18. You're right.
No, because one teaspoon is equals to 5 ml, right? So 3
No. Let's not talk about
right?
cc's or ml's yet. Just teaspoons and tablespoons. Right? 3 teaspoons, 1 tablespoon. If I had 6 tablespoons, of course, well, how many are you gonna have? Right? If I have 6 sets, 6 sets
You
of
just
3,
carry that
that's 18.
to the top.
Oh, okay.
But
So
how
you
would you set it up?
Okay.
Like if you're gonna do this method, you'd set it up like this.
Okay.
Right? If it's a 4,
Maybe 4 teaspoons.
then it would be that.
Be 12.
So you could see this part, different color. You could see how this part right here, that's this part. And the conversion is this. That's essentially the ratio proportion method. You're making a ratio and proportion based on what you don't know versus what you know.
So it's what you do to one side, you do to the other side.
Yep.
That's how you get your answer.
Yep.
Only when it comes to teaspoons and tablespoons.
No, you can do it with any ratio proportion because that's math. Okay?
Oh, right.
Let's say for example, let's take out t's and tables. Let's just do it like this. X over 4 equals 3 over 1.
So we carry the 4 on the top.
Yeah.
In times it.
4 times 3, 12. X times 1. X equals 12.
But we don't get the, okay, it's like fraction, but we don't
Yeah.
get the,
Remember, it goes fractions, proportions, and all that. It's the same thing. Because what's this? It's 1 to 2. What's 1 over 2? Right?
Right, 100.
Which is what? 50%. Remember the chart I drew?
Yeah.
It's all the same thing. It's just different ways of looking at it. So if you have a 1:2 ratio, right? Fraction is a half, and that's what? Chapter 2 stuff. The stuff I could ask you. Stuff I've already asked you on previous quizzes and homework. And then I could ask you to convert it to what? Percent. What does percent mean? Per 100. Right? So
So that would be X if you take x and x equals 12 put it into a ratio form, it would be 1.1. What is that little dot? What's those dots?
This dot is what? Ratio.
No, what's the dots are called? Those two lines, those dots above each other. What is it?
This one?
That's
Yeah.
ratio.
Those are ratio.
Yeah, I don't know.
So that's
In English, it's a colon, but I don't know what.
Okay.
I don't know what it is in math. In math, I just call it the two dots. And when I
Okay.
see that, I think what? I think ratio. I think one, and then because I think on one side is this many, and on this side is this many. That's all I think.
Okay, so 12 in ratio format would be one dot over dot.
So
two.
12. Let's kind of add this to our review. Let's take all this out. If I had the number 12, it's 12 over 1. 12 is to 1. 120%.
120%.
Oh, actually, more than 100%. 1,200%.
How do you get that percent?
Let's do something we know. 1. 1 is 1 over 1. 1 is to 1. That's 100%.
Right.
12 times 1 is what? 1,200. It's just a different way to look at it. That's why I don't look at all those chapters as separate, like your fraction chapter, decimal chapter, percent chapters. In your math, I see it all as one. I see it all as one thing.
You
And it's easy-
basically multiply.
Yeah, just multiply. And it makes sense, right? Like what's 12? Or 12 over 1 times 1 over 1? 12 over 1. 12 to 1. 1,200.
So in the case where the fraction is 42 over 36, you still multiply 32 over 46?
So,
What is larger number?
what, 32 over 46?
Yeah.
So you have 32 over 46. First you have to do what? You gotta break. First you can break it down, right? Because what's 32? Is 16 times 2, or 16 is 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And what's 46? Is 2 times 23.
6 times.
So this, 2, 4, 6, 8. 2 times 4 is 8. So it's 16 over 23. So now that I reduced it, right? 16 over 23. Can I apply it to this model? Of course I can. 16 over 23 is equal to 16 is to 23 is equal to, now how do I get the percent?
Multiply.
Now remember, 16 over 23, I get my handy dandy calculator. Right? Because remember, decimals, ratios, all of it is the same thing. So if I go to my calculator and I look at it as what? 16 divided by 23 equals 0.695. Remember our chart?
Do you always take the first three numbers, or if there's a remainder?
When there's a remainder like this that has extra, I round it off. This one is probably like 696 around, 695, 696, around that. But I'm just illustrating to get the point out. In order to get this decimal, just 16 divided by 23. Then you got this decimal. And then when you see this decimal, when you see it like that, right? Remember the 100%? How do you see it in decimal form? Think of it like dollars. How many cents in a dollar? 1.00, or 100 cents to make $1. So if you see a number like that, if you know like 100% is this, right? 1.00, then you got to know that 0.695 has got to be what? 69.5 or 70%. And if you round it up to 70%, I'll take it. It's the same thing. That is probably 10 items, give or take, 8 or 9 items in your midterm. Being able to convert things. Like I'll ask you, okay, the number 12, how much is that in percent? Right? This fraction, how much is that in percent? I'm like, oh, I don't know.
It would be
Right?
1.20.
So what can I do? 16 divided by 23, I got that number, and then I do what? I just move percent, right? If it's over 100, what are you going to do? Move the decimal 2 places. Boop, boop. Good.
So 1200 would be 1.20 or 12.0.
12.00, because 12 divided by 1 as a decimal, what does it look like? That's what 12 over 1 looks like as a decimal. If I physically take 12 divided by 1, what will my calculator tell me? It'll tell me that. And that, you already now know, okay, I want to make that into a percent. What do I just do? Move it over. 1, 2, 1200%. And also, you kind of can do it empirically, like kind of use common sense. If I know that 100% is 1.00, 12.00 has got to be what? 1200%. Because this is 100%. What's 12 times of that? 1200%.
Okay.
And a lot of, you got to know this going back and forth, because remember what I stated in chapter 2, a lot of meds in this world are calculated per weight, per age. Weight, age, for a whole bunch of things. There are also more advanced medications for kidney stuff. Let's say, for example, my patient is a chronic alcoholic. I'm not going to give them full dose. They're not going to be able to handle it because their liver is what? And based on the liver function test, let's say the liver function test say, oh, their liver is operating at 40% of capacity. What must I now do? I got to lower meds what? 40%. So knowing how to do these little calculations. Now, honestly, the pharmacy tech, the pharmacists, are not the ones really calculating it, but you guys are my second line of defense. You guys should be checking it. Then who else checks it? Nursing staff, right before they give it out. The problem is, does everyone really check every little thing? When they don't, that's when we get into trouble. When we miscalculate medications, it's not one person's fault. There's a whole bunch of people who didn't do their job. Everyone from the tech, the nurse, the doctor, the pharmacist. Okay, didn't check the numbers. And when you think about it, it's a pretty neat system. Multiple people checking multiple things, so that when I give meds to you, or when the nurse administers meds, that it should be what? Accurate. And how many times that the last person who checked it found the problem? How many times a nurse or an orderly went, Dr. Garais, this is messed up. And you look at it and went, oh boy. I checked it. I thought it was good. The nurse checked it. She thought it was good. My attending checked it. He thought it was good. Pharmacy, before they dispense it, they thought it was good. And the tech, or the person who was there, just about to give it to the patient, did what? Did the right thing, did the math, and figured it out. And a lot of boo-boos happen in regarding meds, pediatrics. Because remember, you can have 2 kids, same age, 2 very different weights, 2 very different body types, and that has to be calculated for. But essentially, all those calculations are done the same way that we've been showing here. So, let's look at that. Okay. If you look at the next set of things, it's the same thing, right? How many tablespoons are in 2 cups? Okay, so you could set up a proportion, right? Because you know that 8 fluid ounces equals 1 cup. So you put that proportion there. And what do you want? You're given 2 cups, and you want to know how many fluid ounces. So you can do the proportion, right? X times 1, right? And 2 times 8, answer would be 16. Or, you could do my version, right? Oh, there's actually 2 parts. Now you got how many fluid ounces that are in 2 cups. Now you need to know how many teaspoons. So you can just pretty much take it a step further. But if you look at my version, right? 2 times 8 is 16. 2 times 2 is 16. 2 times 8 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 is 16 right here, you could see that, let me show you my version and how that my version can account for multiple, I'm not going to have too many of these kind of questions, but it can account, I need to show you this, so it can account for multiple conversions, which is what this is. You converted it once here, and then another time here. So let's start off this problem at the very top, and this is page 136, if you're looking at home, example 5.1.2. And I'm going to draw it right here in the board. Okay, so what do we know? And this is my method, or empirical method, or what the textbooks call dimensional analysis method. I call it the no-brainer method because I'm not really using math. I'm just setting up the problem properly. So I want to know how many tablespoons are in 2 cups of this meth. Okay. Now, this requires 2 conversions, because one conversion, I have 2 tablespoons in 1 fluid ounce. And I have 8 ounces in 1 cup. So you can see how I'm going to need to jump to one, then to the other. But let me show you my method, and the method is also in the book, but it doesn't go through all the steps. Okay? So let's go through all the steps. What do I have? I started off with what? 2 cups. And what do I want? Tablespoons. Okay. Can you see how we typically set it up? So then I do my ratios. What do I want goes at the top. Tablespoons. So what conversion do I have? 2 tables and 1 ounce. So I put what I want on the top. And then 1 table is to 1 ounce. So 2 tablespoons is 1 ounce. Now, when you look at it, the ounces won't, when I multiply it all out, I'll have cups, tables, ounces. So that's how I know I'm not done. Because if I do it mathematically, I'll have what? 4 cups. What's a cup's tablespoon ounce? That doesn't make any sense. So, and you're given 2 conversions, so you know you're not done. So what do? I do it again. Now, what do I want on the top? Tablespoons. So what has to get, what do I have to get rid of? Ounces. So I put ounces on the top. I also got to get rid of cups. Cups on the bottom. Now, how many ounces per cup? 8 ounces in 1 cup. Now, when I cross everything out, cups are on the top, right? That gets rid of these cups, right? Ounces are on the bottom, ounces here up top. That'll get rid of that. Now, what can I do? Can I just now multiply out? 2 times 2 is 4. 4 times 8, 32. So my answer, 32 tablespoons. Another way you could do it is, you could do it one problem at a time. So if I do this, I'll have 4 tablespoons per ounce. And then do another conversion, 4 tablespoons per ounce, and then you do the cups and ounces. You could do it in 2 steps. No matter which way you want to do it, you have to make sure that all of these things cancel out, and what should you have left? What you wanted. And that's essentially medicine. You define what you know, what you don't know, and what you need. What do we know? I know I started with cups. Because what else do I know? I have conversions. And what do I need? Tablespoons. So tablespoons have to go in the what? The end. Okay? So you could see that this is potentially a 2-step, but I like my method, what the book terms as dimensional analysis method, because it's just one big step. And you saw that I'm not really using math, any real math skill. I'm using you know, like an accounting method. Like, do I have all my ounces? Yes. Do I have my cups? Yes. Do I end up with what I want? So this is a no-brainer way because let's say, for example, I mix this up, right? I put the 1 and the 8 on the wrong thing. If the ounces were on the bottom and the cups were on the top, I'll be left with cups table. That doesn't make any sense. Right? That's personally how I see it. And actually, that's how if I'm doing calculations for meds, that's how I look at it. And this is also how chemists look at things. They don't like the ratio thing because it's too much math.
Does it really matter? Because 2 tables equal 1 ounce. You have that in the...
Yeah, or you could create, you know, you could create your own conversion already here already.
No. You have the 2 on top as a numerator. And then it says 1 cup equal 8 ounce. But the 1 is in the denominator spot. Where I'm thinking, does it really matter if the 1 cup was above the 8 ounce?
Yeah, it does, because what if I switch this? Right? Let's say, for example, like I got confused. Let's say, for example, I did this. Like I didn't put my labels and I'm like, oh, this conversion. I need to use this conversion and I did this. Can the ounces cross out mathematically?
You cross out mean like this?
Yeah, it'll be ounce. So your answer would be 2 times 2 is 4 times 1. So 4 over 8. So that'll be 1/2 tablespoons. Or it wouldn't even be 1/2 tablespoon. It'd be 1/2 cup squared table ounce squared. You see that the units won't cancel out. And in order for a unit to cancel out, you have to have 1 on the top and then 1 on the bottom. This, they're both on the bottom. This, the cups, they're both on the top. So then you can, and also, let's say you just did the math. It wouldn't make any sense. Okay, 4 over 8, 1/2. So 2 cups equals 1/2 tablespoon? Then you know you were wrong. And that's the beauty of math. You can see that you're wrong and then do what? Ooh, oopsies.
So tablespoons are always whole numbers, or are they
In real life, no.
fractions?
Because sometimes we convert. Because remember, in real life, the meds could be in metric, and the delivery system that you have could be in standard or household. That's the problem in real life, and that's actually the problem here in the United States. Residents mess up the conversion. And like I shared, especially in pediatrics. Like for example, we'll be going over in a couple of minutes that in real life, teaspoons and tablespoons, sometimes I have to mix it in a drink. I don't mix teaspoons and tablespoons. I'll mix cc's and ml. And ml is what? Metric. And we're going to talk about that in a moment. But just concentrate on these types of problems, right? And no matter what conversion, these these strategies work for either one. Let's go to one where, because the rest of the examples are pretty much the same thing. And I'm not going to have too many of where you have to take, 2 different conversions. 1 conversion at a time. But can I take some of these multiple conversions, make one part of the conversion, one problem, like a number 2, and then the next part of the problem will be what? Number 3. So it keeps it separate. And ultimately, let us now go over this. Because this is bread and butter as well. Meaning to say is, you do a lot of this in the real world. Okay. So we're now on page 139, and the conversion between household measure and the metric system. Because again, meds are usually, and here is your conversions. Meds are usually done in the metric system, because many of the medications either are made in other countries or marketed towards other countries. So, if you let's say for example, your Ciba Geigy, which is a pharmaceutical company. You do business with 38 different countries. The only country that does household is the United States. So what would you make all your meds? Make all your meds metric, because the majority of your customers are under the metric system. So we're constantly converting these kind of things, and especially trying to talk to mommy and daddy who don't have your training, and trying to tell them how to read the little, the little numbers on the little cups that come with the meds. It gets really confusing. So it's sometimes just better, like, you hand them the little teaspoon and you go, okay, you do it to this line. Sometimes when I was in pediatrics, I even put a little piece of tape. This is where you put it. Put the medication up to here. And actually, a good office will actually, okay, we're going to give your baby a dose today. Can you show me how you would give dose? And then they'll show you, and then that's actually the best way on how to assure what they call compliance. Compliance means, are they doing what you told them to do? And are they doing it consistently? So we look at that. The teaspoons are 5 ml. And we know that there are 3 teaspoons in 1 tablespoon, so that 1 tablespoon's got to be what? 15 ml. And remember, ml is the same thing as cc, because sometimes you can convert this stuff into a syringe. Because let's say, for example, my patient is taking IV meds. You cannot make them eat it, right? So you have to have a different kind of medication, and it's got to be converted. Fluid ounce is about 30 ml, a cup 240, a pint 480, quart 960, a gallon 3,840. Now, I'm not going to ask you to memorize a cup, pint, quart, gallon, but definitely you need to know teaspoon, tablespoon, and fluid ounce, because it's very common. And regarding weight, what's very, very common, and what's definitely going to come out, is 2.2 pounds equals 1 kilogram. You got to know that. That happens every day. Actually, a lot of doctors' offices, they'll tell you your weight in pounds, but on the scale, the medical assistant or nurse will put down your weight in kilograms, so that when we're calculating meds, I don't have to convert it. Okay, let's look at it. And again, here's a nice little picture. So now you're going to see things more like it is 5. And this is how I remember it, 5, 15, 30. That's how it pops into my head. And also, that's how I know that there are 3 teaspoons in 1 tablespoon. Alrighty. So let's do this one example. 5.1.6 on page 140. And remember, another type of question that could have any label that is that's within the body of your chapter, or that's within the body of any assigned homework, is fair game. I will not use the same problem, but can I use the same label? So that is hydrocodone. Very dangerous, right? Bitartrate, and it's got acetaminophen in it, oral solution. So this is pretty much Tylenol with codeine. Okay? So, let's look at what we know. And I'm going to now go to the board.
I can't even access my books when I used to be able to.
Right after class, go see Lori and then show her so that she can see what's up, like why you can't see it. But I'm putting this video, and this video already, like, when I have a problem that I discuss, I always rewrite it up here on how you would write it on an exam, or how you would figure it out. So let's look at this. What do I know? I've got Tylenol. I go Tylenol with codeine, so that's the meds. 300 ml of this stuff. So this is what I know. 300 ml or 300 cc's, same thing. Now, if I look at the label, okay, the label will tell me right there, and it's a little bit fuzzy, that it's 7.5 milligrams for 500 ml. So this is how much drug that is in half a liter of this stuff. Okay? 7.5 milligram for 500 ml. And it is in 15 ml. So that's the concentration, right? This is the dose. Okay? Now, the prescription states that my patient is supposed to get 15 ml of this stuff. The prescription states the patient takes 2 teaspoons twice a day. Okay? These things in parentheses are the abbreviations because remember, some of the labels that we have, not some of the labels, almost all of them, are in that, you know, that abbreviation mode. So teaspoons, BID. So I have to take 2 teaspoons of 15 cc's or 15 ml a day. So I'm taking 2 teaspoons per dose. Okay? So, right off the bat, what do we know? And I'm not doing anything. 2 teaspoons. How many ml are in 1 teaspoon?
5.
5. So if I have 2 teaspoons, how many ml do I now have?
2. 10.
Oh, 2 times 5 is? Good.
10.
10. So we already know right off the bat. That's 10 ml. Alright? Now, because if I take 10 ml and I take it 2 times a day, how much volume for a whole entire day am I taking? 20. Good. So could this be a multiple choice question? Yeah. A, 10, 20, 30, 40. How many do I take per dose? 10. How many am I taking per day? Dose is the one time. Right? How many are you taking per day? 20 ml. Now, let's get into the tricky one. Okay? Let's say I dispense 300 ml of it. Okay? It's a bottle of 300 ml. Okay? Now we already know. How many days supply is 300 ml? So I start off with 300 ml times. And then how many do I want? Days. How many do I know? Do I use this conversion or this conversion?
10.
That's per dose. I want what?
Day.
Day. So I put what I know, day, right on the top, and ml would be on the bottom, and I use this conversion. So the 20 would be on the bottom, and that's to answer your question before. Like, how do you know where to put it? Does it matter if it's on the top or the bottom? It does. Because now that I define day over ml, right, where does the ml go? The 20 goes where the ml goes. And day, 1 day. 300 divided by 20, or 30 divided by 2, how many days supply does my patient have? 15, which is a lot. It's probably,
What? Hold on.
this is probably state of Virginia, why we're giving so much dose.
That's because it's 30 days. 30 days in.
No, not the,
Like,
no. Now let's go over it. Let's start from the beginning again. Let's try it again. Okay. What did we figure out right here, even before we started? Even before we started, this is what we figured out. Per dose, you're dispensing how much? 10 ml, because you know it's 2 teaspoons. But per day, you know the patient has to be hit what? Once in the morning, once at night. Twice a day. So that's what? 20 ml. We're all agreed on how to figure this out. Okay? Those are your conversions, so you don't touch it. Right? This is on the side. Now, if you look at the question on page 140, it asks, how many doses will be dispensed if I gave my patient 300 ml? So, how do we do that? We start with what we know. What do we know? 300 ml. Times. Then I put my conversion equals, then my box of what I don't know, and how many doses I go, how many doses will be dispensed well, first it asks, okay, let's,
I thought it was 2.
oh, how many doses? Let's do that one first. So, if I want how many doses, Which conversion will I use? The 10 ml per dose or the 20 ml per day?
10 ml dose.
Okay, so I put dose on the top because that's what I want to end up with, and I put ml on the bottom. Now you see 10 goes with this, with the ml, so I put that there.
Dose 1.
Dose is of course 1. 300 over 10,
30.
right? 0 cancels out, so it's what? 30 doses.
Okay.
Now, my question was, how many days supply do I have? Well, we start out with what we know. 300 ml times, and then I want to know how many days I have until she runs out, because she's got to come back. This is for pain, for a significant amount of pain. So she's got to come back. So I use this one because it has days in ml. I put the ml on the bottom, days on the top because that's what I want, and it's 20 ml per day. So 300 divided by 20, that's what? 15.
So in a case where she has to take it 4 times a day,
Then
it would be 40 ml
well,
per day.
I wouldn't be given this much Tylenol.
Just in case, because you know sometimes in a book they put out crazy questions.
Yeah, but it wouldn't matter like if I changed any of the numbers. What matters is what matters is did you get the process down?
The days would change in that.
Yeah, the answer of course will change. But let's say for example, I don't want to do teaspoon. I don't want to do because usually with pain medication of that level, we're usually what? Titrating down. You don't want to. When you start increasing meds, you end up like, you know, like that doctor who took care of Michael Jackson. It's going to get out of hand. You're always trying to, with pain medication, titrate down. You don't want the patient on extended pain medication because remember, your pain meds from your pharmacology is Schedule II drugs. Very, very high potential for addiction, especially that stuff. Wow. And also, remember what I told you. This is the real world. Do you think that a patient could be faking it to try to get drug off you? Yep. And that's why in other states we don't give this much dose. If my patient is in this much pain, I want her to see me again in 3-4 days, because I want the pain to start going down and then start taking her off this massive amount of drug.
So in the situation I was talking about, we was talking about 300 ml times, and we're looking for the days, and they want them to take the medicine 4 times a day.
Yeah. So let's do that. Let's say, for example, we're going to change up. The problem.
Would it be dose or day?
So let's say, for example, we're gonna change what?
The day.
She's in real pain. I want to take her 4 times a day. We already know that we're doing what? We're doing already 10 ml per dose. Now that she's got 4 times a day, how many ml now?
40
It's gonna be 40.
per day.
Now how much supply does she have? Even
40
less.
times
So we do what? We do what we know. 300 ml times. How many days we have? We put the ml on the bottom, put what we want on the top, the days. So 1 day she takes 40 ml. 300 divided by 40, 30 over 4. That's what? She's got enough for a little over 7 days.
A little over 7 days?
Yeah.
What did I do wrong? 30 ml.
300 divided by 40.
300.
Because what's 40 times 7?
Oh,
280,
40.
right?
Right.
So let's do it calculator-wise. Calculator, 300
7.5.
divided by
A little over
4.
7.
Yeah, she's got 7.5 days.
A week and
A week and
half a day.
a week in like the morning. So you can see no matter what parameter I change, the process is always the same. Don't try to memorize what to put on the top, what to put on the bottom. Memorize and learn the process. How did we figure out these steps?
Okay.
Now, another question, since we're kind of mix and matching the review with this lecture, is can I have this label? I can have this label out, right? I can ask you, how much is inside this bottle? And you'll tell me what? 300 ml. What is the concentration, and you go, of this bottle?
7.5.
7.5 milligrams per 500 ml. That's the concentration. This stuff here is stuff that we figured out because we know from the problem that's stated on page 140 is that we gave 2 teaspoons. And if we're giving 4 times a day, it would no longer be BID, it'll be
Q.
what? QID.
Because 2